make sure you have your introduction to matter notes, and we're going to do the 1.2b, what is mass, what is weight, mini lesson. So by the end of this, you'll be able to compare and contrast mass and weight and explain why weight changes depending on the planet or moon. And then you'll be able to define mass and weight. So recall that matter is anything that has mass and takes up space. So we looked at different examples of matter and non-examples of matter. Right now we're going to look at what is mass. So mass is the amounts of atoms an object has. Remember, if you need to pause the video, you can pause to write, but you're going to write anything that is in red. You can always add more if you want, but the basic is writing down the red. So we've got a mouse here and we've got an elephant here. The mouse is way smaller, so it's going to have less atoms in it, so it's going to have less mass. The elephant is larger, more mass, more atoms. So we're thinking about space. Mass is actually the same. No matter where you are, whatever planet or moon you are on, the mass is always the same. So this astronaut here is on Earth. His mass is 100 kilograms, and then his mass is 100 kilograms on the moon. So the mass is the same. Remember, make sure you write down the red. You can write down the black if you want to, but you have to at least just write down the red. So then what is weight? So weight is the measure of gravitational force on an object, right? We have gravity on Earth. That's why if you drop your pencil on your desk right now, it will fall and hit the table. It doesn't just float in the air. And that's because of gravity. So gravity is pushing down on this little boy on Earth, and that is what adds weight to him. So looking back at our example here of the astronaut on Earth and the astronaut on Moon, the gravity on Earth is higher than the Moon. So that means something on the Earth is going to have more weight than something on the Moon. So you can see this astronaut's weight is 980 N, which is newtons on Earth, but then it's only 162.2 newtons on the Moon. So this video is a little blurry, or really blurry actually. It's from the 70s, it's from Apollo 16. These astronauts went to the moon. You'll see this astronaut come in the frame, and you'll see him jump, and it's slower for him to go to the ground. It's going to look like it's in slow motion, but it's actually not. It's because there's less gravity. So let's watch the little clip here. So it looks like this is in slow-mo, but it's not actually. Watch, he's about to jump. And it takes a little bit longer, right? If we jumped, you would just immediately fall on Earth. And that's because the moon has less gravity versus the Earth. Okay, to summarize with this boy, so his weight on Earth is 560 newtons, and his weight on the moon is 90 newtons because the moon has less gravitational force, but his weight is always the same. So, sorry, his mass is always the same. So his weight's going to change because different places have different gravitational forces, but his mass is always going to stay the same. He's still made of the same amount of atoms, no matter where he is.